Redefining habitability. Nature's determination to surprise us extends beyond planetary physics into perhaps the most profound question of all. Are we alone? The extreme conditions on these rebel worlds force us to confront an uncomfortable possibility that in limiting our search for life to Earth-like conditions, we might be overlooking countless alien biospheres hiding in plain sight. For decades, astronomers focused their search for extraterrestrial life within a narrowly defined Goldilocks zone, that special orbital region where a planet could maintain liquid water on its surface. Earth harbors life and has liquid water, so this approach seemed logical. But as our planetary catalog has expanded to include worlds with glass rain, lava oceans, and exposed cores, are we trapped in a tunnel of possibilities, viewing the universe through an Earth-centric lens that blinds us to other forms of life? The discovery of these cosmic rebels has forced astrobiologists to recalibrate their entire approach to searching for life beyond Earth. Each impossible planet serves as a reminder that the universe has far more imagination than we do. If planets can exist in configurations we once thought impossible, perhaps life, too, can arise and thrive in environments we'd previously dismissed as utterly inhospitable. The broader approach to habitability dramatically expands the potential real estate for life in any given solar system. Consider the enormous ring system surrounding J1407b. Within those complex bands of material, containing roughly an Earth's worth of matter, scientists have detected gaps suggesting the presence of forming moons. These exomoons, developing within this dynamic environment, could potentially harbor conditions suitable for life, not on their surfaces but beneath them, much like Jupiter's moon Europa or Saturn's Enceladus in our own solar system. These moons might maintain vast subsurface oceans kept liquid by the gravitational tug-of-war between the planet and its parent star. These hidden oceans would be shielded from radiation by thick ice crusts while still receiving the heat necessary for liquid water. The tidal forces exerted by gas giants like J1407b could generate enough internal heat to maintain these subsurface oceans for billions of years, potentially long enough for life to emerge. This possibility expands our understanding of where life might exist, as gas giants like J1407b appear to be relatively common throughout the cosmos. Even planets that seem decidedly hostile might have more to offer than we initially recognize. Worlds like HD 189773b, with its sideways glass rain and extreme winds, demonstrate that planetary systems can produce remarkably diverse environments. While the planet itself might be utterly inhospitable, its existence points to the diversity of worlds that might orbit the same star. For every scorching hot Jupiter we detect close to a star, could temperate, rocky worlds orbit at greater distances, invisible to our current detection methods. The ancient planet Methuselah pushes our thinking in an entirely different direction, chronological rather than environmental. If planets could form when the universe was just 1 billion years old, then life may have had the opportunity to emerge and evolve for nearly 13 billion years in some parts of the cosmos. This timeframe dwarfs Earth's 4.5 billion-year history and the roughly 3.7 billion years that life has existed here. What forms might life take given 3 times longer to evolve than terrestrial organisms have had? Methuselah's existence extends the timeline for possible biological evolution far beyond what we'd previously imagined. Even a planet with conditions as extreme as TOI 849b, an exposed planetary core subjected to incredible heat and pressure, expands our thinking about planetary evolution. If gas giants can lose their atmospheres or fail to fully form, then the development of potentially habitable worlds might follow similarly unexpected pathways. Could worlds that begin their lives as gas giants transform into terrestrial planets with conditions suitable for life? A planetary evolution path entirely unknown in our solar system, but potentially common elsewhere? The James Webb Space Telescope represents humanity's most powerful tool yet for investigating these possibilities. With its unprecedented ability to analyze the chemical composition of exoplanet atmospheres, JWST can detect potential biosignatures, gases that might indicate the presence of life. Astronomers are now casting a much wider net, examining the atmospheres of diverse worlds, including those that orbit in configurations once thought impossible. One particularly exciting frontier in this expanded search involves exomoons orbiting massive planets in binary star systems. While no specific exomoon has been definitively confirmed yet, the presence of objects like Methuselah, which orbits a binary system consisting of a pulsar and a white dwarf, demonstrates that planets can form and persist in complex gravitational environments. If planets can exist in such systems, moons likely can too, potentially offering stable environments where life could emerge. This broader approach acknowledges that our single example of a life-bearing world, Earth, might represent just one possibility among many. Life on Earth evolved under specific conditions, but there's no reason to assume those conditions represent the only pathway to biological complexity. The chemistry that underlies terrestrial life might function in environments drastically different from Earth's surface, or alternative biochemistries might exist altogether. Even Trace 2b, the darkest world known, prompts questions about unconventional habitability. Its near-complete absorption of light means its thermal profile differs markedly from anything in our solar system. While the planet itself is unlikely to harbor life as we understand it, its existence demonstrates that planetary characteristics can vary far more widely than we once imagined. Could habitable conditions arise in equally unexpected configurations? We now recognize that potentially habitable environments might exist in places we never thought to look. In subsurface oceans of distant moons, on rogue planets drifting between stars, in the clouds of Venus-like worlds, or in the atmospheres of gas giants. By breaking free from our Earth-centric definition of habitability, astronomers have dramatically expanded the search for extraterrestrial life. As we've explored these 7 extraordinary planets that defy conventional understanding, we're witnessing just the beginning of a cosmic revelation. With more than 5,630 confirmed exoplanets already cataloged, our journey of discovery is accelerating, not concluding. The James Webb Space Telescope and Habitable Worlds Observatory will analyze alien atmospheres with unprecedented detail, transforming our understanding of what's possible. These missions invite you to join humanity's greatest adventure, uncovering worlds stranger than fiction. What undiscovered planets might circle the stars you see tonight? Each point of light may harbor revelations that challenge everything we know about our vast, boundlessly creative universe.